All right, in this video, we're continuing to simplify expressions that have rational exponents. Let's look at example A here. We have 9 over 25 to the negative 3/2 power. So first thing we want to do is to write all exponents as positive numbers. So to do that, we can actually do a simple trick, which says that if we were to apply this negative 3/2 to both the top and the bottom of the fraction, so we'll have negative 3/2 here and negative 3/2 there, which is the way you distribute in this exponent, correct? Then from there, I can just simply reciprocate the fraction, making it 25 to the positive 3/2 power over 9 to the positive 3/2 power. Remember, if you flip the fraction, the exponents change their signs. Okay, so at that point, it's just a matter of evaluating those two pieces. Now remember, you can actually separate the rational exponent so that it's 25 to the 1/2 power raised to the 3rd power. Because again, remember, when you distribute in that 3, it would be the same as what we have written here. Okay, now, same thing for the 9 at the bottom. We'll do 9 to the 1/2 power raised to the 3rd power. The reason why that's helpful is because anything to the 1/2 power is the same as the square root. So 25 to the 1/2 power, of course, is just 5, and that will be then raised to the 3rd power. And for the denominator, 9 to the 1/2 power is just a square root of 9. That'll be 3, and then we have the exponent of 3 out here, so it'll be 3 to the 3rd power. And 5 to the 3rd power turns out to be 125, while 3 to the 3rd power turns out to be 27. All right, let's look at example B then. For example B, we have a very similar problem. We're going to go ahead and do the same thing we did before. We'll apply the exponent into the numerator and the denominator. So we'll have 27 to the 2/3 power, and we'll have 8 to the 2/3 power. Then from there, we can rewrite it so that we swing this 1/3 over to the front, and we end up having the 3rd root of 27, and then we're going to put it to the 2nd power because of this exponent up here. Do the same thing with the denominator. We're going to end up having the 3rd root of 8, and that will be, again, raised to the 2nd power when we're done. So we're using the same procedure we used above, just moving a little bit faster to rewrite it. Then from there, the 3rd root of 27 is 3, and you'll be squaring that afterwards. And the 3rd root of 8 is 2, and you'll be squaring that afterwards. So you'll end up having 9 over 4. Okay, final example, example C. For example C, it's a little bit simpler. We're going to be multiplying, common bases that have these exponents 3/4, 1/3, and negative 1/2. The rule when you're multiplying something with the same base, right? Whenever you multiply 2 terms or 3 terms with the same base, you keep the common base and you add the exponents. The addition is a little bit troublesome here because we'll have 3/4 plus 1/3 minus 1/2. And the problem with that is we have to have common denominator to be able to add those expressions. So what we're going to have to do is say, what is the common denominator for the fractions that are in the exponent? So I think the common denominator between 4, 3, and 2 is 12. Because if we count by the bigger one, the 4, right? If we count by 4, we'd have 4, then 8, then 12. And the first number that all 3 of those denominators go into is 12. 4 goes into 8, and 2 goes into 8, but 3 does not, so we couldn't use 8. 4 goes into 12, 3 goes into 12, and 2 goes into 12, so 12 will work. So with that in mind, we're going to rewrite all of this so they have a denominator of 12. All right, so we're going to need to rewrite all these fractions with denominators of 12. So we might have, for example, 3/4 is going to be something with a denominator of 12. Well, from here to here, we multiply by 3, right? So we'll need to multiply the top by 3 as well. 3 times 3 is 9, so the 3/4 will become 9/12. Then we'll have a plus sign. All right, the next fraction we have to rewrite is 1/3, so we need to get 1/3 to have a denominator of 12. Well, 3 times 4 gives you 12, so it must be 1 times 4 for the numerator. So we'll have 4/12, so 4 on top there. And then finally, we need to rewrite 1/2 as something with the denominator of 12. So 2 times 6 gives you 12, therefore it must be 1 times 6, or 6/12. And it'll be negative because 1/2 is negative in this problem. All right, so after rewriting all of those fractions, we can finally do the thing we wanted to be able to do in the beginning, which was to add those exponents. So 9 plus 4 will end up giving you 13, and then you subtract 6, you'll get 7. So it'll be 7/12 as the fraction. And that's the answer.